Sustainable building refurbishment design also needs to enhance the indoor environmental quality. Healthy and comfortable employees are often more satisfied and productive. Unfortunately, this simple truth is often lost, for it's easier to focus on the first cost of the project than it is to determine the value of increased user productivity and health. Facilities should be constructed with an appreciation of the importance of providing high-quality interior environment for all users. IEQ encompasses indoor air quality, which focuses on airborne contaminants, as well as other health, safety, and comfort issues, such as aesthetics, potable water surveillance, ergonomics, acoustics, and lighting. IEQ improvement to existing building can occur at any point during the use of a building, especially during refurbishment. No matter how sustainable a building may have been in its design and construction, it can only remain so if it is operated responsibly and maintained properly. For example, the use of toxic cleaning products can deteriorate indoor air quality. Failure to test sensor control points on a regular basis can compromise energy efficiency, and poor training can lead to an early system failure. Sustainable operations and maintenance practices focus primarily on the actions of building occupants and encompass safety, health, and comfort and productivity. With an understanding of the need for subsequent generations to reuse and recycle building components, during the design and construction process, to the maximum extent possible, select systems that will be easy to maintain. Ensure that operation and maintenance personnel are part of the project planning and development processes, such as by establishing commissioning criteria at the onset of a project. Let's look at sustainable materials for refurbishment. Careful selection of environmentally sustainable building materials is the easiest way for architects to begin incorporating sustainable design principles in buildings. Traditionally, price has been the foremost consideration when comparing similar materials or materials designated for the same function. However, off-the-shelf price of a building component represents only the manufacturing and transportation costs, not the social or environmental costs. A sustainable material is one that does not deplete non-renewable natural resources, has no adverse impact on the environment when used. In a refurbishment project, it is very likely that numerous materials are changed, replaced, or installed. Considerations should be given in the selection of building materials to meet the objectives of sustainability. Special features of sustainable or green materials include the following. Pollution prevention measures in manufacturing. Pollution prevention measures taken during manufacturing processes can contribute significantly to environmental sustainability. Selecting materials manufactured by environmentally responsible companies encourages their effort at pollution prevention. Water that is used abundantly in the production of cement and metal. This wastewater is often released directly into streams and can contain toxic substances. Colored dyes used for carpet are environmental contaminants that escape freely into the waste stream. Waste reduction measures in manufacturing. The waste reduction feature indicates that the manufacturer has taken steps to make the production process more efficient by reducing the amount of scrap material that results. Reducing waste in manufacturing process increases the resource efficiency of the building material. Wood composite materials are made up of almost entirely waste scrap. The sawdust generated on site is used to power the kilns. Water used for cooling equipment or mixing can be filtered and reused rather than discharged into the waste stream. Recycled content. A product featuring recycled content has been partially or entirely produced from post-industrial or post-consumer waste. The incorporation of waste material from industrial processes or household into usable building products reduces the waste stream and the demand on virgin natural resources. Aluminium can be recycled for a fraction of the energy required to transform raw ores into finished goods. Other materials that can be recycled include glass, plastics, metals, concrete, timber, and bricks. Here you can see some examples of the recycled products that can be created from the wastes. Again, recycled materials that can be used for roofing, okay, for carpet, okay, for floorboard, okay, paving. Recycled material to give you the ceramic tiles. Embodied energy reduction. The embodied energy of a material refers to the total energy required to produce that material, including the collection of raw materials. The greater material's embodied energy, the greater the amount of energy required to produce it, implying a more severe ecological consequences. The processing of timber involves far less energy and releases less pollution than the processing of iron. Use of natural materials. Natural materials are generally lower in embodied energy and toxicity than man-made materials. They require less processing and are less damaging to the environment. Many, like wood, are theoretically renewable. When natural materials are incorporated into building products, the products become more sustainable. Reduction of construction waste. Minimum construction waste during installation reduces the need for waste disposal and also provides cost saving. Concrete, for example, has traditionally been premixed with water and delivered to the site. An excess of material is often ordered to prevent pouring delays should a new shipment be needed. This excess is usually disposed of in a landfill or on site. Concrete mixed on site as needed eliminates waste and offers better quality control. Taking advantage of standard sizes of building materials in design phase reduces waste produced by trimming materials to fit, as well as labor costs for installation. Designing floor intervals to coincide with standard lengths of timber or steel framing members also reduces waste. Energy efficiency. Energy efficiency is an important feature in making a building material environmentally sustainable. The ultimate goal in using energy-efficient material is to reduce the amount of generated energy that must be brought to a building site. The long-term energy costs of operating a building are heavily dependent on the materials used in its construction. Preferred materials slow the transfer of heat through the building's skin, reducing the need for heating or cooling. Water conservation. Products with water conservation features address efficient use of water, as well as an overall reduction in the volume consumed. Water-saving shower heads and toilets are now widely used in residential as well as commercial buildings. Water from cooking or hand washing may be channeled into flush toilets. Captured rainwater may be used for gardening. Water-saving shower heads and toilets can be introduced in residences and commercial buildings. Use of non-toxic or less toxic materials. Non or less toxic materials are less hazardous to construction workers and the building's occupants. Many materials adversely affect indoor air quality and expose occupants to health hazards. Some building materials, such as adhesive, emit dangerous fumes for only short period of time during and after installations. Others can contribute to air quality problems throughout a building's life. Sick building syndromes occur when natural or artificial ventilation is inadequate to remove odors and chemicals emitted by certain materials, for example, particle board, paint, ammonia, or cleaning solution and varnishes. Durability. Materials with a longer life relative to other materials designed for the same purpose needs to be replaced less often. This reduces the natural resources required for manufacturing and the amount of money spent on installation and the associated labor costs. Durable materials that require less frequent replacement will require fewer raw materials and will produce less landfill waste over the building's lifetime. Low maintenance. Less frequent cleaning of material reduces the exposure of the building occupants and the janitorial staff to cleaning chemicals. This is especially important for surfaces or systems that must be cleaned with petroleum-based solvent. Reusability. Reusability is a function of the age and durability of the material. Very durable materials may have many useful lives of service left when the building in which they are installed is refurbished or decommissioned, and may be easily extracted and reinstalled in a new site. Windows and doors, plumbing fixtures, and even bricks can be successfully reused. Windows, doors, bricks, plumbing fixtures can be successfully reused easily. Steel framing members can be salvaged carefully and reused for similar purposes. Recyclability. Recyclability measures a material's capacity to be used as a resource in the creation of new products. Steel is the most commonly used or recycled material, in large part because it is easily separated from construction debris by magnets. Many building materials that cannot be reused in their entirety can be broken down into recyclable components. Concrete cannot be reformed once it is set, but it can be broken up and used as an aggregate for non-structural purposes. Biodegradability. The biodegradability of a material refers to its potential to naturally decompose when discarded. Organic materials can return to Earth rapidly, while others like steel takes a long time. An important consideration is whether the material in question will produce hazardous materials as it decomposes, either alone or in combination with other substances.